everybody, this is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to see how to find out the half-range sine series, which is the last topic of Fourier series in linear algebra and calculus. Already in this topic, Fourier series, we have seen many the intervals, that is 0 to L, minus L to L, 0 to pi, minus pi to pi, minus L to L. All these different types of intervals we have seen, and we have learned how to find out the Fourier series in different cases. And in all the interval, the common thing is we need to find out the three Fourier coefficients A0, An, and Bn values. Sometimes if you know that the function is even or odd function, then you can reduce a few Fourier coefficients. Even that also we have seen. And the last session we have learned how to find out the half-range cosine series. And now we will take half-range sine series. And let's see which coefficients we need not work it out, and which coefficients we have to work it out. Half-range Fourier series. The half-range Fourier sine series defined in interval 0 to pi. The half-range sine series 0 to pi is given by f of x is equal to summation n raises from 1 to infinity bn sine nx. So among the three Fourier coefficients, that is an, a0 and bn, we need to find out only bn value. Only one value is enough to find out the half-range sine series. In half-range sine series, the two Fourier coefficients a0 and an both will become 0. So this is a similar to the Fourier series defined in the odd function from minus pi to pi. So half-range Fourier sine series in the same, here I have taken the interval 0 to pi. So let's see what the formula is from in the interval 0 to L. So the half-range sine series from 0 to L is given by f of x is equal to summation n rises from 1 to infinity bn sine n pi x by L. This is the only difference, because if you see here we can observe that if L is equal to pi will get cancelled and we are left out with sine nx by nx, right? Okay. The same thing we are doing it here also. N pi x should be there. N pi x by L should be there here. Okay. So this is similar to the Fourier series defined for the odd function minus L to L. So let us find out this half-range sine series with one example. Find the half-range sine series for f of x is equal to 2, x raises from 0 to pi. So for every problem we need to put the formula first. So the half-range sine series is given by f of x is equal to summation n raises from 1 to infinity bn sine nx. So here we need to find out the bn value. So what is the bn value? Bn is equal to 2 by pi integral 0 to pi f of x sine nx dx. F of x, what is the function given? The function is nothing but 2, a constant. So 2 into sine nx dx. Right? So 2 into sine nx dx, and which is nothing but 2 by pi. Integral of sine nx is nothing but minus cos nx by n. So minus cos nx by n. 4 by pi minus cos nx by n from in interval 0 to pi. So which comes out to be minus this 4 by pi, if you apply the upper limit, minus cos n pi minus cos of 0, which is 1, divided by n after applying. But this value is nothing but minus 1 whole to the power of n. So this comes out to minus, I have taken outside 4 by pi minus 1 whole to the power of n minus cos 0 is nothing but 1. So this is how I wrote it here. So 4 by n pi 1 minus 1 whole to the power of n is a bn value. We got it for the half-range Fourier series for f of x is equal to 2. So just we need to substitute here. F of x is equal to summation n rises from 1 to infinity bn sine nx. Bn is nothing but 4 into 1 minus 1 whole to the power of n by n pi into sine nx is as it is. Now you expand by that is open the summational value by putting n is equal to 1, 2, 3 so on. So 4 by pi 2 into sine nx sine n is nothing but 1 here in the first term. Okay, n is equal to 1, 2, 3 so on. So we will get it as 2 sin x by 1 plus 2 sin 3x by 3 plus 2 sin 5x by 5, so on. So in all the terms, 2 is common. You take it outside. So 4 into 2, that is nothing but 8. 8 by 5 sin x by 1 plus sin 3x by 3 plus sin 5x by 5 is an expansion for f of x is equal to 2 in the interval 0 to pi. So this is a half range expansion for the given function. So let us see one more example. Expand f of x is equal to cos x in the interval 0 to pi. That means I'm going to find out the Fourier sine series. So what is the Fourier sine series of any function is given by f of x is equal to summation bn sine nx nx. What is the bn value? Bn value is nothing but, here I have already wrote it, that is nothing but 2 by pi integral 0 to pi f of x sine nx dx, sine nx dx. So if you substitute the n is equal to cos here, cos value, and find out the bn value, resubstitute to get the Fourier sine series. So let us see what we are going to get. So bn is equal to 2 by pi integral f of x sine nx dx, limits from 0 to pi. Here the product of the two functions is that first we will reduce into the single function by using 2 cos a sine b. So 2 cos a sine b, that is nothing but sine sum plus sine difference. Okay, 2 cos a sine b, multiply and divide by 2, and we will use the formula from trigonometry, that is a trigonometrical transformation, that is nothing but 2 cos a sine b is nothing but cos sine sum plus sine difference. We will use this formula here. So before doing the integration, so cos x sine nx can be written as sine n plus 1 into x plus sine n minus 1 into x. N is not equal to 1, because if it is equal to 1, totally it becomes 0 here. So here integral of sine n plus 1x, that is nothing but minus cos n plus 1 into x by n plus 1. And integral of sine n minus 1 minus cos n minus 1 into x by n minus 1. We know that cos nx is nothing but minus 1 whole to the power of n. Then what is cos of n plus 1 into x, which is nothing but minus 1 whole to the power of n. Okay, these formula helps you to write the expansion form. Otherwise, we'll get it in cos x, cos 2x, like that. So minus 1 whole to the power of n plus 1 by n plus 1. Plus minus 1 whole to the power of n minus 1 by n minus 1 minus 1 by n plus 1 plus 1 by n minus 1. So write it in the least form by taking minus 1 whole to the power of n as common. If I take this as common, minus 1 whole to the power of n plus 1 plus minus 1 by n minus 1 minus 1 by n plus 1 plus 1 by n minus 1. So this can is the least form. It is brought at 2n by pi into n square minus 1 into minus 1 whole to the power of n plus 1. So I got the Fourier coefficient, single Fourier coefficients, which has to be substituted in the Fourier expansion. That is f of x is equal to summation n rises from 1 to infinity bn sine nx. So this value have to be, this total value has to be substituted here to get the Fourier expansion, that is f of x is equal to, therefore the Fourier series is half range sine series. Half range sine series is given by is given by f of x is equal to summation n raises from 1 to infinity 2n by pi into n square minus 1 into the minus 1 whole to the power of n plus 1 into sine nx. So this is the expansion for the given function, that is cos x in the interval 0 to pi. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.